So here are two tough pictures that we have to be able to work with when it comes to the 30, 60, 90. So I call this the 30, 60, 90 tough stuff. This to review real quick. Remember, we have two 30, 60, 90s right here. On the left one, right here on this left one, if it starts with a hypo, remember we go through the middleman to the little leg. The little leg is half the hypo, so this would be 150. And then we go to the big leg, which is little leg times radical 3. So there's a little review. Just one more time on the second one here, on number 2. If this is a little leg, and I know it's a little leg because it's across from the 30, so that is our middleman. So we can go to both the hypo by doubling it, and then to the big leg by just multiplying it by radical 3. So hopefully those aren't too awful. But here is a situation that we're going to have to do a little formula, a little trick here. So what if the big leg is a whole number? We want the big leg to be that little leg times radical 3. But what if it doesn't have a radical 3 to take off? That's what we want to see. So there's a little trick, a little formula we have to have, and it's kind of similar to the formula for the 45, 45, 90. So here is how we go from big leg to our middleman, the little leg. This is how we do it. If the big leg has no radical 3, it's a whole number, we take that big leg and we divide it by 3 and times it by radical 3. That is the formula if big leg is a whole number. So if I take the big leg, I divide it by 3, which would be 6, times it by radical 3, I now have the little leg. So how would I get to the hypo? How would I double the little leg to get to the hypo? Well, it's 6 radical 3 times 2. That's how you get to the hypo. And so now it's 6 times 2, and we don't touch the radical 3. We multiply the two whole numbers and leave the radical 3 in the back. So let's see two more examples like that. So on this first one here, I have 9, a whole number in the big leg, so it's across from the 60. So we're going to use our formula. It's going to be big leg divided by 3 times radical 3. So our middleman here to get to the little leg is going to be 9 divided by 3 times radical 3. And then to get to the hypo, we're going to take 3 radical 3, our little leg, times 2. It's double. So we multiply just the whole numbers, which would be 6, and leave the radical 3 alone. Okay, this is number 2 here. We have another picture of a big leg being a whole number. So this would be our little leg, our middleman. So that's going to be 39 divided by 3, which is 13, and put a radical 3 behind it, times 3. Now, to get the hypo, we are going to double the little leg. 13 radical 3 times 2. And that comes out to be 13 times 2 is 26, radical 3. Alright, so there's one more thing we got to look at with the 30, 60, 90, and that is we're going to have to know how to 30, 60, 90s work with equilateral triangles. Okay, So anytime we're working with an equilateral triangle, you know that there are 60 in each corner. So how are we going to work with equilateral triangles and see a 30, 60, 90? So in an equilateral triangle, a lot of these questions are going to say something called an altitude. An altitude basically is another word for height. So here's me drawing an altitude down the middle of this. It's a height, and it's also taking a pair of scissors and cutting along this red dotted line and cutting it perfectly in half. Cutting the right triangle, or the equilateral triangle, perfectly in half. So what will you get? What will happen if I cut along that line is what we're going to have are two 30, 60, 90s. And they are also going to be equal to each other. So they will both have equal hypos. Okay, so down here will be the little leg. And basically that dotted line is the big leg for both of them. It's across from both 60s. So, how does this work? If I have my first equilateral triangle here, and it has a side length of 12. Well, let's think about it. We already said that these two, A and B, these two triangles are equal, 30, 60, 90s. So that means they're both going to have a hypo of 12. Well, equilateral triangles have equal sides, so yeah, that's going to be 12. Also, this whole bottom side is going to be 12. But if we cut it with that altitude, it's going to be two 6s. And look at that, because that's going to be across from the little. That's going to be across from the 30. It's the little leg. It's half the hypo. It's 6. It's half of 12. So the altitude is going to be the big leg, and it's going to be little leg times radical 3. So that means that big leg in here is going to be little leg times radical 3. So what happens if they start with the big leg? Let's say this thing has an altitude, I'm just going to use A for altitude, is, let's say, 10 radical 3. Okay, so that means I'm going to 10 radical 3 here. And if I were to imagine this being a single 30, 60, 90, I'm going to go to the middle man, the big leg, or I'm sorry, the little leg, and I'm going to take that radical 3 off. And it's going to be 10. So here's a 10, and here's a 10, because these two things are equal. I mean, both of these triangles are equal. So if one right side has a 10, left side has a 10. Then I go to the hypo by multiplying it by 2. So the hypo would be 20. And each side of our equilateral triangle would be 20. But what would the perimeter of this thing be? Well, it would be 20, 20, and 20. The perimeter of this would be 60 if they asked for it. So there is some tough questions on 30, 60, 90, the two things we're going to have a little trouble with, and we just got to practice makes perfect.